Welcome to Live Sound for small to medium-sized venues. This is the second video in our four-part video series on live sound. This video will focus on sound distribution, and that is basically the speaker systems that you're going to use to provide sound to the people in the front of house and also the monitor speakers for the performers on the stage. So a brief review introduction. In part one of this series, we stated the speakers are the most important component in determining the sound of your sound system. And the argument there is speakers are what's known as an electromechanical component. You put an electrical signal into a speaker, you get mechanical action in the speaker, which creates sound coming out of the speaker. And if you could compare the sound signal coming out to the electrical signal coming in, they are not typically an exact match. There are some very good speakers where it's a close match, but there are also lots of speakers where it isn't a very close match. There's a lot of color added to sound by speaker systems, and everything that you do goes through your speakers. That's why they're the most important component. Things like the electronics add much less color, if any, to the sound. Microphones can color the sound a lot, but they're typically only one per channel or one channel each. They're not everything like the speakers. So this is really a key video in this series. We also established that if you look at musical instruments, certainly the types of musical instruments we're most commonly concerned with here, there's really no or very little musical content below 40 hertz. The only way you're going to get anything below 40 hertz would maybe be an electronic keyboard, something like that. Massive pipe organs can do that, but you're probably not going to encounter that in this kind of setting. So very little musical content below 40 hertz. So the focus here is on speaker systems that can produce good sound from 40 hertz and up. And so in this video, we're going to discuss how do you select these speakers, how do you set them up, and how do you run them to achieve good sound. So what is a good sounding speaker? So there's been some great work done on this by Floyd Toole and Sean Olive. Floyd Toole was, I believe, a professor at McGill University in Canada. Sean Olive was a graduate student there getting his PhD. With support from the National Research Council of Canada, they did a tremendous amount of research on speakers. What is a good speaker? They both work for Harman International now, which is the parent company of JBL, among other things. So they're part of a company now. So you could always say, well, are they, going to promote their particular speaker brand? But if you look at this research, it's not like that at all. This is basic acoustic research. It's basic principles kind of stuff. And they did this very, very well done, very comprehensive work. And it's really hard and expensive to do this kind of work. And the fact that they have a lot of resources behind them is actually a really good thing. So in audio, there is an enormous placebo effect. If you believe a component is an expensive, good component, you are more likely to like the sound. It influences your decision-making a lot more than people want to admit or realize. So what they do is they put up a curtain that you can't see through. They put speakers behind it so you don't know what speaker you're listening to. The curtain is acoustically transparent, and they have this big mechanical apparatus that moves the speakers around so that when you're listening, you have the speakers you're listening to are right in front of you. And they very carefully level match them and do all these things. And they make sure that the listeners, they test them to make sure they have good hearing. Because you have somebody that can't hear high frequencies, they're liable to like a speaker that has way too much high frequency content, trying to compensate for their hearing loss. So they make sure they have good hearing. They make sure that, they're trained in how to listen to speakers. And they do all these tests, and it's done double blind. The person listening has a button they can press that will switch speakers, but they don't know which one they're listening to. And even the people involved in the research don't know until the end when the computer puts out all the results. And the people put in and they say, well, this is what we like and don't like about the speakers, and they score them. And they've been able to establish this. And with these groups of listeners with, dozens and dozens of different speakers and over long periods of time, and they can get consistent scores for the speakers. And then they take the speakers and they measure all the things they can think of to measure about it. And they try to figure out what measurements correlate to good sound. This is really important because, if you're if you're working at Harman International and you're going to design a speaker, or you're working at Electric Voice or any company and you're going to design a speaker, what's your design criteria? Oh, well, I want it to sound good. Okay, well, what do you design for? So by doing this work, they have measurable criteria that you can design for. And so what they found in this work is that it correlates, good sound consistently correlates with flat, smooth frequency response on axis. That means you're sitting right in front of the speaker. It's flat, smooth frequency response. Secondly, as you move away from that axis, you move off to one side or the other of the speaker, you need to maintain that flat, smooth frequency response, right? If you move a small distance around in a room or something in front of a speaker and the sound completely changes, that's a problem. And when you think about live sound, where you're trying to cover a large area, you really need the speaker's frequency response to be consistent over a pretty broad area in front of the speaker. Secondly, you want extended flat bass response. Bass is one of the most difficult things to do with a speaker. It is the most difficult thing to do with a speaker. And it's something that, it's pretty easy to sit there and go, oh, the speaker has no bass or it doesn't have any bass, or it has good bass. And so that's really a telling characteristic. And then the third thing is an absence of audible resonances. Okay, a resonance is, say you have a speaker cabinet and a particular frequency causes that cabinet to vibrate a lot. That's a resonance, and that will create a peak, or it can create a valley in your frequency response, and it can be very sharp because it's a specific frequency that will cause it to vibrate or to ring. And if you don't design your speaker and your speaker cabinet correctly, and it rings at a particular frequency, that's going to mess up the frequency response. And, more information on this, if you're interested in learning more about this, if you go on YouTube and you just search for Floyd Toole or search for Sean Olive, there's a bunch of videos up there where people interview them. They're very interesting people to listen to. They have a lot of really great stuff to say about this subject. These are two of the leading experts in the world on this. So here is an example of what an ideal frequency response curve would look like. In the first part of this series, we talked about, live sound, you want 40 hertz up to about 16 kilohertz covers most people. The fact of the matter is, going below 40 hertz is extremely difficult. Going above 16 kilohertz is a piece of cake. It's very easy to make drivers that go to 20 kilohertz, which is the agreed limit for human hearing. And in fact, some speaker tweeters will go to 30 or 40 kilohertz. That's not really that hard to do. So your ideal speaker would have flat frequency response over this range. So here we are, you're on axis, and this is what an ideal curve would look like. It's completely flat. Here's 40 hertz. This type of plot on the bottom here, this is what's called a log plot. It's kind of a strange thing if you haven't seen it before. This is 20, 30, 40, 50, 60, 70, 80, 90, 100 hertz. So it's in tens. Then this is in hundreds, 100, 200, 300, 400, 500 to 1,000. And then it's in thousands, and then it's in 10,000s. It's just a way to be able to cover this wide range and display it and show the detail in each section of it. But the key here is, here's 40 hertz. It falls off very rapidly before 40 hertz. 40 hertz is our goal, and it's completely flat all the way out here. And I'll show you a curve for a particular speaker later. There's always going to be, on real speakers, there's always going to be some ripples in this curve. There might be, in some cases, huge dips, huge deviations from this. But this is an ideal curve. And if you look at a frequency response plot for speakers, most of the manufacturers produce those plots. You can look at them. If the curve would have dropped down here, for example, you wouldn't have much bass. If it dropped down up here, it would be very dull sounding. You wouldn't have the highs. If there was a lot of ups and downs here in the mid-range, which is where your ear is most sensitive, you'd have all kinds of strange things for the speaker. So for live sound, what do you want, right? So, flat frequency response, 40 hertz to 16 kilohertz. You want it to be sensitive, right? You want this speaker to be able to play loud without requiring a lot of amplifier power. And you want the speaker to be able to handle a high amount of amplifier power so that it can produce loud output. If you look at home speakers They are not designed for this. You might think, oh, my speakers in my living room, they get so loud. Well, how big is your living room? 15 feet by 20 feet, 12 feet by 18 feet. That's not like doing a hall that's 50 feet by 150 feet or 70 feet by 200 feet. They're much, much louder. So you need much more powerful or much more efficient speakers that can really produce a lot of sound. And directionality, you want the speakers to have a specific and controlled directionality. And we'll cover that in a minute. So when you look at a speaker, when we talk about a speaker, what we're really talking about is a cabinet, and it's got speaker drivers in it, one or more speaker drivers in it. And so here's what a speaker driver looks like. So you've got the outside of it, which is just this sort of metal frame, called a basket that's out here. And in the middle here, you have this cone. And the cone here and here, for a long time, these were paper. Nowadays, they might be paper, but they're coated with a bunch of stuff. They could be plastic, polypropylene. In some cases, they might even be metal. But what you want is this cone is what's going to move and make the sound. You want this cone to be very rigid. You don't want it to have any specific resonances, particularly in the sound frequency range that you're interested in. And this cone is suspended. There's a little thing here called a surround, which is rubber or foam. There's one here and one here. And then there's this spider here, which is a sort of a pleated flexible material as well. And that allows this cone to move in and out like this. And then the bottom of the cone here has a coil of wire wrapped around it. And that is suspended in this magnetic field here. You've got a permanent magnet here. When you put electric current through this coil, it creates a magnetic field and with these magnets, and it causes the cone to move. And so as the signal goes through here of the music you want to produce, it causes the cone to move, in response to that signal. And that creates vibrations in the air, this cone movement back and forth, which is sound, which comes out of this driver. Now, one thing to keep in mind here, which we'll get to in a second, so you have sound coming off the front of the speaker. This basket is not sealed. You don't want it to be sealed because you would have air being compressed and basically contained here, but not here, and the cone wouldn't move evenly. So the back of this is open. So sound comes out the front, but sound also comes out the back. Now, I said bass is the hardest thing to do with a speaker, and here's why, and here's what the problem is. So as you go to low frequencies, as basically from a high frequency as you go down in frequency, every time you cut the frequency in half, you have to move 4 times as much air. Now, at high frequencies, that doesn't matter because you don't have to move very much air. The diaphragm doesn't have to vibrate very far. But as you get to these low bass frequencies, the diaphragm has to move a tremendous distance, or it has to be really big to move enough air. And this graph over here shows, in order to make 110 decibel sound level, here's an 8-inch speaker, a 12-inch speaker, and an 18-inch speaker. Over here we have plotted frequency, and what you see here is as the frequency goes down, the excursion, how far the cone has to move, increases. And the problem that you run into here, so if we go right here, this is 20 hertz, and we go up and we say 20 hertz, with an 18-inch speaker, it only has to move 2 to 3/10 of an inch, okay? That's not a problem. 18-inch speaker can make 20 hertz, no problem. The problem with an 18-inch speaker is the cabinet it's going to be in. The cabinet has to be sized in order to handle. It doesn't have to be sized just big enough to hold the speaker. It has to have enough air volume in it to deal with some other things that go on. You're talking about a cabinet that's going to take 2 people to carry. It's going to be gigantic. Okay. If we go up here to a 12-inch speaker, for 20 hertz, it's still over an inch of excursion. Maybe an inch and a half, something like that. It's very hard to make a speaker with a lot of excursion. That voice coil comes out of the magnetic field, out of the gap. As you get to the edges of that magnetic field, it starts to behave very badly. You don't really have good control over the speaker. So, like an inch of excursion in a like 12-inch or an 8-inch woofer is a lot of excursion. So over an inch of excursion, you're really, not going to do that. So 12-inch woofer is really probably not going to do 20 hertz bass for you. And an 8-inch speaker, you're talking 3.4 inches of excursion for 20 hertz, which is just not going to happen. Okay, so the point here is if you want to do 20 hertz bass, you're going to need a really big speaker with a lot of excursion. And, by the way, as we've talked about in the first video, there's really not much down there anyway, right? A bass guitar starts at 41 hertz. A kick drum is more like 50 hertz. So if instead of 20 hertz, we move up here to 40 hertz, now you've got a 12-inch woofer at 40 hertz. It's moving 0.3 of an inch. That's very doable. And I'm going to show you later in this presentation an example of a 12-inch subwoofer that has excellent performance down to 40 hertz and you can pick one up in each hand and walk with them easily. And even down here at 40 hertz, you're still, for an 8-inch woofer at 40 hertz, you're over an inch of excursion, so you're probably not going to do that. But as you get up here more towards 60 or 80 hertz, now an 8-inch woofer can handle that. Now, I said that speaker driver puts sound out the back and the front. And the problem with that is the sound coming out the front, when the cone moves forward, it's pushing air out the front. It's kind of sucking air in the back. When it's going back, it's sucking air, or it's making a negative pressure from the front and a positive pressure from the back. So it's 180 degrees out of phase, and the front and the back. And so the sound from the back can interfere with the sound from the front. So you need to do something about that. So you put this in a cabinet. And there's two ways to do this. You can seal the cabinet up and you can fill it with absorbing material. And you have to make the cabinet, it has to be big enough for this to work right. But it basically, all the sound that comes off the back of the speaker just goes nowhere. It just gets captured in the cabinet and it goes nowhere. But you're wasting half of the sound output. So why not try to find a way to take advantage of the sound from the back? Well, you can, if you design the cabinet, it's the right size, and sometimes there'll be baffling in it to create a pathway, and then they put a vent in the side of it, a port, an opening. And if they do all this right, you can actually get the sound from the back to come out the front in phase with the driver in front. And now, if we look at this graph over here, here's a sealed speaker. And I mean, at 100 hertz, it's already falling off. We get this vented cabinet, and now the venting of the cabinet provides improved bass. You have this little bit of a peak here. Depending on how you design it, you can minimize that. And you can get the bass to go out quite a bit further than if you have a sealed cabinet. So it goes further, and it's more efficient. And this is, very common. PA speakers that you see are almost always going to be vented. There's also a thing you can do called horn loading to make them more efficient. That tends to be pretty big. So you're going to see that almost every, subwoofer or woofer cabinet you're going to deal with is going to be vented. There is some drawback to this. Vents they can ring a little bit. They can, they can cut down on the ability of the speaker to react rapidly to changes in the music to some extent. But for live sound, it's a really good trade-off, and most cabinets will be vented. Okay. This slide won't make sense until the next slide. This is setting up the next slide. But if you look at, in the first video, we showed these sound waves, and they have a frequency. So if we look at a 20 hertz note, that is a sine wave that's going through 20 cycles per second. So each sound wave is 1/20th of a second. Right? It happens 20 times a second. It's a 20th of a second. Sound moves at a specific speed. And so if you say, okay, in 1/20th of a second, how far does sound travel? It travels 54.3 feet. And so a bass note is 54.3 feet long. If you're vibrating at 40 hertz, 40 cycles per second, then it's only traveling 27 feet. 80 hertz, it's traveling about 14 feet. So the higher the frequency, the shorter the sound wave is. And the reason that this is important, so we've been talking about how do you design a speaker driver to get good bass response, right? And we talked about you want it in a vented cabinet, and it needs to be really big, needs to have really long travel or excursion. That's great, okay? But that creates two problems for you. So when the wavelength of a frequency becomes comparable to the size of the driver starts to become very directional, okay? So on this slide that we just looked at, we saw that the wavelengths, as you get to higher and higher frequencies, start to become very short. And so you have this 12-inch or 15-inch or 18-inch woofer, and now it's going to start to become very directional. And as we'll see in a minute, we want speakers to cover a certain area. And you're going to have parts of the speaker designed to cover that wide area, but now the woofer is only going to cover a very narrow area. That becomes a problem. The other thing is the large, heavy diaphragms for these low frequency drivers, they do not vibrate efficiently at high frequencies, so they don't make high frequency very well. Okay, so we mentioned coverage. So these are common coverage patterns for live sound speakers. 90 degrees. So, it would cover this 90-degree angle in the front here. The sound would come out. It would spread out at a 90-degree angle. And here's a 65-degree angle. And I picked these specific ones because speakers that we're going to look at as we go through this presentation, one of them is a 90-degree and the other one's a 65-degree. And the differences in usages for these speakers, the 90-degree speaker is going to cover the area right in front of the stage really well, but it's not going to reach out as far. The 65-degree is not going to cover as much area right in front as the 90-degree, but because the sound is more concentrated here in this central area, it will send sound farther. So if you've got a small room, people are relatively close to the stage, this would be a great solution. If you have a really big room and you're trying to get sound all the way to the back, you're going to use this. Now, there's nothing to preclude having more than one speaker, for example, on each side of the stage. So you could have multiple 65-degree speakers pointing in all different directions to cover an area if you wanted to, and they would throw the sound a long way. But that's the importance here. And it brings us up to, what we were talking about. If you have a low frequency driver, you put a big, if you put a big 18-inch woofer in this speaker here, as you start to get to high frequencies, it's only going to cover the middle part here, right? At low frequencies, the sound will actually wrap completely around the speaker. Even with an 18-inch driver, you're going to have low frequencies all the way around the speaker. But as the frequency goes up, it's going to come in narrower and narrower and narrower, and pretty soon you're going to be inside of this 90-degree coverage pattern. And even on this 65-degree, it's going to be inside the coverage pattern as you get to high frequencies. So what do you do, right? The low frequency driver does not make high frequencies very well, and it becomes too directional as you go to higher frequencies. So that brings us to drivers for mid and high frequency. So what you do is you have your low frequency driver, and these will be 8-inch, 10-inch, 12-inch, 15, 18-inch, large, heavy diaphragm speakers. These are referred to as woofers, and these will do the low frequency. And then you will have another driver mounted in your it can be in the same cabinet, it can be in a separate cabinet, but it's going to be small. It's going to be a small, light diaphragm, specifically designed for high frequencies, and these are called tweeters. And they maintain high efficiency and wide coverage at high frequencies. Because they're very small, even at high frequencies, they're not that directional. And the other thing, the trick you can do with these tweeters too, is because they have really wide coverage, you can couple them to like a horn, and the horn limits their directivity to a specific range. So if you want to make a 90-degree speaker, you put a 90-degree horn on there, and everything coming out of the tweeter is 90 degrees. If you want to make a 65-degree speaker, you put a 65-degree horn on there, and everything's 65 degrees. But again, that's your high frequencies and maybe some of your mids, depending on your speaker design. You still need to have a woofer, a low-frequency speaker, that you are only using for frequencies that are wide enough to meet that coverage pattern. If you let the woofer produce frequencies that are too high, it'll be too directional, and your speaker will now not have even coverage across the entire frequency range. And that'll make it so that as you move off axis, like some mid frequency will disappear. So you need to make sure that your woofer is only doing the right band of frequencies. And then there's intermediate size and weight drivers that you can add for mid frequencies, which are called mid ranges. Now, well, how do you do that? Well, so you have something called a crossover. And the crossover is an electrical circuit. You feed your sound into it, and it splits it up into frequency bands. And so it would basically take the sound coming into the signal coming into the speaker or coming into the crossover, and it would split it so that the high frequencies go to the tweeter, the low frequencies go to the woofer. If you have a mid-range, well, and if it's a two-way speaker like that, some mids will go to the tweeter, some will go to the woofer. If you have a three-way speaker, it'll send the highs to the tweeter, the mids to the mid-range, and the lows to the woofer. And there's two types of crossovers. A passive crossover is built into the speaker. And what happens is you have your amplifier hooked up to the speaker, driving the speaker. You have this very high-level, very powerful signal coming into the speaker from the amplifier. So the crossover, all the components in the crossover have to be really big. They have to be able to handle a lot of power. And you're not going to make it a very complicated crossover. You're not going to have a lot of electrical components, electronic components in it, because they're really big. And it's going to take up a lot of area, and it's going to dissipate a lot of heat, and it's going to get really expensive. So these passive crossovers built into speakers tend to be fairly simple crossovers. They'll have a particular frequency. Everything above that frequency goes to the highs. Everything below that frequency goes to the lows. I shouldn't say everything, because there is basically what happens is at this frequency, as you go below the frequency, less and less of the highs go through. And as you go above the frequency, less and less lows go through. But there is a crossover period to it. And how sharp that is and how sophisticated it is and whether there's a little dip there where you cross over from one to the other, all depends on how good this passive crossover is. And, it's relatively difficult to make these. And if you have a three-way cabinet, now you have your mid-range, your highs, and your lows. So you got to split it three ways. The other way to do this is what's called an active crossover. An active crossover does the crossover while the signal is still a small signal before it goes through the power amplifier. And the advantage to this is now you can have this very complicated circuit because they're really tiny, small components. You can use something called integrated circuits that can have very complicated circuits. You can even do it digitally. You can, in a digital domain, you can do the crossover and then convert it back to analog, and that opens up a whole bunch of things to you. You can do all sorts of really fancy corrections and all sorts of really cool things. The downside to an active crossover is when the sound comes out of the crossover, it's now already split before you go through the amplifier. And so instead of having one amplifier to drive your speaker, you need an amplifier for the tweeters, an amplifier for the woofers, and if you have a mid-range, you need an amplifier for the mid-range. So instead of feeding all the sound through one amplifier and then splitting it in two or three ways, you've split it two or three ways, and now you have to have two or three amplifiers. But it has some really nice advantages in terms of the quality of the crossover, and there's something to be said for having amplifiers that are each dedicated to a frequency band, because the lows, the amplifier driving the woofer is going to be working really, really hard, and that can make it so it's not really doing such a great job for the mids and the highs. So by separating that out, there's some advantages to that as well. And I'm going to show you some of the speaker systems I'm going to show you. Actually, we do kind of a hybrid approach, a little bit of both. So here are some examples. For small to mid-sized sound systems, the main speakers that you encounter, the speakers that feed out to the audience, are going to be typically two or three-way speakers. You can pair them with a subwoofer. You can have a two-way system plus a sub, which would effectively be a three-way setup, or you can have a four-way setup, which is basically a three-way speaker plus a sub. You're going to see as I go through this, I personally only use two-way speakers. I haven't felt the need to spend the money and get the bigger, heavier three-way speakers. I use two-way speakers either by themselves or with subs, depending on the circumstance. In theory, having this, three-way speaker with a mid-range is going to get the sound a little bit better. But there's some really great sounding two-way speakers, and I have never felt the need to go that way, but you certainly can. So here's a two-way speaker. The sound comes in from the amplifier. You've got this crossover here. And some of the mids and all of the highs go to the tweeter. Some of the mids and all of the lows go to the woofer. And that's your speaker. With a three-way speaker, the sound comes in from the amplifier. The high frequencies go to the tweeter, the mids go to the mid-range, the lows go to the woofer. There's some, in the crossover frequency range, a little bit of mids go to the woofer, a little bit of lows go to the mid, a little bit of highs go to the mid, a little bit of the mids go to the tweeter. But as you go from this two-way to this three-way, there's less of that. The other thing that's really important to understand here, a lot of these systems are built in such a way that the crossover is built in and it's hooked up to these speakers. If you were to say, well, you know what, I don't want to use this internal passive crossover, I want to use an active crossover, and I want to have a separate amp for this tweeter and a separate amp for the woofer, a lot of speakers won't let you do that. They're sealed up, the crossover is built into them. There are some that can do that. If you're going to use active crossovers, you're going to use separate amplifiers for your tweeter and your woofer, or your tweeter, your mid-range, and your woofer, you're going to need to make sure the speakers that you buy support that. And sometimes it'll be as simple as on the outside back of the speaker here, there'll be multiple sets of connections, and there's just a little jumper between them that you can pull off, and then you can separately address them. But you need to be aware of that, because you go buy a really nice three-way speaker with a built-in crossover, and then you buy a bunch of amps and an active crossover and think you're going to bypass the internal crossover, and then you find out you can't. You just spent a lot of money. So I mentioned a few minutes ago that you want your system has to be able to put high output for live sound, because generally you're covering a much larger area. And so you want these speakers to be very efficient. You want them to be able to play loud. And generally, if a speaker is very efficient, it can get very loud. And so I have three speakers listed here. All three of these are Electro Voice speakers. I listed them here because these are the speakers that I use. These are the speakers that I have a tremendous amount of experience with. And I'm going to talk more about how I use these and what these are. And I'll talk about other brands a little bit as we go through this. I've had very, very good luck, very good results with these speakers. The SB122 is a subwoofer. It's a 12-inch woofer driver with a lot of excursion. It has very long excursion for a 12-inch woofer. It's in about a 35-pound cabinet that you can pick one up in each hand and walk with them. And it puts out 99 decibels, 1 meter in front of the speaker if you feed it with 1 watt. So you think about that, 1 watt's not very much power, makes 99 decibels. That's pretty loud for not feeding it much power. And it can handle, this speaker cabinet can handle almost 1,000 watts, so it gets much, much louder. The SX300 is a sort of mid-sized two-way speaker that I use for mains, and I use it with or without subwoofers depending on the job or the gig. Again, it's 99 decibels. And by the way, these are both 99 decibels because they're designed to work together. The SB122 is designed to be a subwoofer for the SX300. I also sometimes use the SB122 as a subwoofer with the ZX190s, and you can certainly do that. It's a more efficient speaker, so you just turn it down a little bit. The ZX190 is a small two-way main, and it's 94 decibels. If you contrast this to home speakers that are often in the 80 to 90 decibel range, if you have an 85 decibel home speaker, and you compare that to this 99 decibel professional speaker, this is going to play over twice as loud for the same power, like 2.5 times as loud. Tremendously more efficient. If you're like a home audiophile guy with these big massive speakers and somebody asks you to, do an event and you're like, oh, my speakers play really loud in my living room, they'll be great. You're really in for a bad evening, because you're not going to be able to make enough volume. I want to talk about passive speakers and active speakers. So passive speakers, you hook up up the speaker to an amplifier, and the amplifier drives the speaker. If you think about this for a minute, right? If you're doing a gig and you need two speakers, you have to bring two speakers and you have to bring an amplifier. So it's three things to bring to the gig. If you have an active speaker, the amplifier is built into the speaker. So now you bring your two speakers and that's all you have to bring. Typically these are set up so a low-level signal is input to the speaker crossover. It has an active crossover built in. And a lot of times there'll be multiple amplifiers in here. There'll be one for the lows and one for the highs. Or if it's a three-way speaker, one for the lows, one for the mids, and one for the highs. And the amplifiers will be designed to work with the drivers that are in the speaker, and it'll all be, designed to go together and to work well. Now, there's pros and cons to this, okay? The crossovers are typically active crossovers. They're going to be more sophisticated. They could be digital crossovers. And in fact, in some of these speaker systems, they even do things like they'll have like a microphone in there that measures what's happening in the speaker, or they'll have a sensor that's on the speaker cone that'll measure what's happening in the speaker, and that will feed back and it will adjust the speaker actively. There's some really cool subwoofers, for example, that do that. So you can have more sophisticated crossovers. The amplifiers are designed or selected for each driver, and it's fewer pieces of equipment for you to bring with you. On the con side, an active speaker is a speaker and an amplifier built together, so they're typically heavier. That's not usually the end of the world. Keep in mind, with a passive speaker, you bring one cord from the amplifier to the speaker. With an active speaker, you bring a cord bringing the signal from your mix board to the speaker, and you have another cord, which is the plug, because you have to plug it into the wall. So everywhere you're going to put one, you're going to need to run power as well as the signal cable. This last summer, I was doing a gig, and I had some monitor speakers up on the stage, and they were hooked back. They were passive speakers. They were hooked back to an amplifier, and each speaker had a 50-foot speaker cord hooked to it. I could move those easily around the stage anywhere I wanted because all I had to do was worry about that 150-foot cord that I was stretching all over the place. If this was an active speaker, I would have had to deal with two cords. Not the end of the world, but you have two speakers on the stage, or 4 or 8, and now you have 16 chords instead of 8 chords. You're moving all this stuff around. It can it can be inconvenient. Now, if you're just setting up the speakers for mains and you're never moving them, it's a little bit different. The other con to this, every speaker has a dedicated amplifier or amplifiers built into it. So every speaker you buy, you're paying for the speakers, the speaker drivers, the cabinet, and the amplifiers. If you buy passive speakers, each speaker you buy, you're paying for the speaker and the cabinet. You're not paying for an amplifier. And at one time, I owned 14 speakers, all passive speakers. So I had 4 of the SP122 subwoofers. I had 4 of the SX300 mid-size main speakers, and I had 6 of the ZX190 small main speakers. I'm down to 4 of the ZX190s now, but I still own 12 speakers. I only owned 4 amplifiers because I never did enough, I never did like multiple gigs at the same time, and I usually only needed like 1 or 2 amplifiers, and I would just I would mix and match the speakers and amplifiers to get the result that I wanted for the job. So it can be less expensive. So it really comes down to what you're doing. Now, if you're a musician who goes out and does gigs and you play by yourself most of the time and you need to bring your own PA, you bring 2 powered speakers and a little tiny mixer, and that's all you need for your PA. That's very attractive. So, there are pros and cons to this. And powered speakers are used for monitors a lot of times. I'll talk about this a little bit when I get to monitors. I have some small powered speakers I use for monitors. So it isn't one's better than the other. It depends on what you're doing, and it depends on how you want to use the speakers. Okay, I debated whether to put this in, right? A lot of people might disagree with me on this. This is just my opinion on some major speaker brands. And I need to put a big caveat here in that I haven't bought a speaker in over 10 years. I have I have my 12 electro voice speakers. I love them. They work great. At some point they'll break or they'll start to degrade, and I'll have to do something. You can get them reconed, or I'll have to buy new speakers. I'm getting to the point, that I don't know how many more years I'm going to be doing live sound. I'm 66 years old. Am I still going to be carting all this equipment around and doing this in 10 years? I don't know. I mean, I have a lot of fun doing it. I like it. But we'll see. So Electro Voice, huge speaker manufacturer. I don't know if this is true at this point or not, but I don't know, about 20 years ago, somebody told me the Electro Voice was the biggest speaker manufacturer in the world, and in fact made the drivers for a lot of other speaker companies. I don't know for sure it was true then. I think he knew what he was talking about. I don't know if it's true now. I tried to do a Google search, and you get a lot of stuff that doesn't make any sense. The other thing too is that there's so many companies now just making these little, powered Bluetooth speakers and things like that. What you really want to know is what are the major brands of professional, PA speakers but anyway, it's a huge speaker manufacturer. This is my favorite brand for small to medium sized speakers. I've never used their larger systems, so I can't comment on whether the really big array speaker systems that they make are any good, but they make the full range. But their smaller speakers I've had really good luck with, particularly the ones that I use. JBL is another huge manufacturer. If you go see, the Rolling Stones or Bruce Springsteen or Aerosmith or the big touring acts, a lot of them use JBL speakers as their system. Some of their budget low-end speakers that I've heard have not sounded very good. So you need to be a little careful that with JBL that you're paying enough money to get into a range of good speakers. Yamaha, I have not personally used Yamaha speakers ever, but Club Passim, which is a venue in Boston, it's a place, Tracy Chapman got her start there. Joni Mitchell played there back in the day, long time ago. When Bruce Springsteen was fairly early in his career, they turned him down when he wanted to play there. That's the rumor. I don't know that for sure. But anyway, they have some Yamaha. They have a pair of Yamaha speakers hanging up to either side of the stage. I think they're 15-inch woofers with horn tweeters. I think that's the size of them. I've been to many shows there, and the sound there is always very good. QSC speakers. They make powered speakers. QSC is a big amplifier manufacturer. They're very good at making very light amplifiers. I know a lot of people that own these. I know a lot of people that love them. The times I've heard them, I've never been blown away by them. Now, maybe that's the people using them. I don't know. And I've been told so there's a new updated version of these, like a Series 2 or something like that. And I've been told by a guy that I really respect who does live sound for a living that they're very, very good. So not trying to disparage these, just I haven't been blown away the times I've heard them. Mackie, I've never used a Mackie PA speaker. I've never been somewhere where I knew for a fact that the sound I was hearing was coming from Mackie speakers. I do have some monitor speakers at home, professional monitor speakers that I use when I'm at home and I've made recordings and I'm mixing the recordings down, and they're spectacular. These HR824 Mach 2s, from the factory, they actually measure the frequency response on every one before they ship it, and they send you the graph. I mean, it's like a ruler. It's incredible. So, presumably they can make a decent PA speaker, but I just don't know. I am not a fan of Behringer equipment, of any of their equipment. I feel like they make very inexpensive but not very well made equipment. If you're using Behringer equipment because it's all you can afford, I respect that. I mean, you can afford what you can afford, and I've gone through that at various points in my career where I've had to do sound with equipment that wasn't what I really wanted it to be because I just couldn't afford it. But I'm generally not a fan, and I try to avoid Behringer gear. I was in a club in Boston one night where they had 15-inch speakers with horns. I think it's part of Behringer's Euro series, and they didn't sound bad. They weren't too bad. So here's an example of a speaker system. We've talked about active crossovers. We talked about two-way, three-way speakers. So here's an example of kind of a hybrid. So in from the mix board comes a signal. This is an active crossover. And what it's doing is everything below 150 hertz, it's sending to this amplifier, which feeds this subwoofer. So this is a passive subwoofer. It's being fed by this amplifier. And above 150 hertz, it's going to this amplifier, which goes to this two-way speaker, which is now splitting the signal with its own internal crossover between the tweeter and the woofer. This is something I do a lot. I'll have a two-way speaker, and it can be either my SX300s, which are a 12-inch woofer with a horn tweeter, or it can be my ZX190s, which are an 8-inch woofer with a horn tweeter. And I might use those alone, or I might use them with a subwoofer. And when I use them with a subwoofer, I use an active crossover, and one amplifier drives the two-way speaker on the top with its crossover doing its thing, and the other amplifier drives the sub. Now, a really interesting thing about this, you take a two-way speaker and you take away everything below 150 hertz and put it in the subwoofer, so the two-way speaker doesn't have to make anything below 150 hertz anymore. It will get incredibly loud because it's not working very hard. You know, your 8-inch woofer is working really hard when you get down to 100 hertz or 80 hertz, working really hard to make any bass down there. It doesn't have to do that anymore. It can get incredibly loud. You got a 12-inch woofer. You know, even a 12-inch woofer down, by the time you get down near 100 hertz, it's starting to work really hard. So now it's not working that hard. This can get really loud. And I'm going to show you specific examples of systems on the next several slides. Okay, so here's the first example. This is the Me and Thee Coffee House in Marblehead, Massachusetts. This is a small venue. I'm not positive. I think this might be one of, if not the oldest continuously operating coffee houses in the U.S. I did sound here, live sound here for several years. And it's interesting because I walked in the door and I look up and here's the speakers. There's one here and there's one here. This is in what's called the sanctuary. It's a Unitarian church. You can get around 100 people in here. And I walk in the door and I look up and I'm like, oh, I recognize those speakers. Those are ZX190s. I have 6 of those. Sort of the second thing I noticed as I listened to them for a while was they don't sound right. And it turned out that this one, the tweeter was blown. So I put a new tweeter in for them and got that fixed. But this is an example. So this is a ZX190 on each side. They're mounted up high, pointing sort of down and out at the audience. You can see on the stage here, this is actually Cheryl Wheeler on the left and John Gorka on the right, two absolutely spectacular folk musicians, and they're, singing and playing acoustic guitar. Okay, now the ZX190s are 8-inch woofers with horn tweeters. They're small speakers, and yet these small speakers are handling 100 people in this room, and it sounds really good. How is that possible? Well, there's 2 key things to why this works, and it works in this environment. It wouldn't work in a lot of other environments. Okay, number one, they're up high. So they're pointed down onto the audience. The sound is reaching the audience, and it doesn't have to. It's not, running into any obstacles before it gets to the people. If these were down on the floor, pointed at the audience, all the sound would be absorbed in the, front rows here, and it would never get to the back of the room. The second reason this works, this is a typical show: acoustic guitar and vocals. Acoustic guitars have no sound below about 80 hertz. Male vocals don't have any sound below about 80 hertz. Female vocals don't have any sound above, below hundreds of hertz. So there's nothing that's really low that these speakers can't handle. Because these speakers, 80 hertz, 60 hertz, they're really at their limit for how low they can go. But you're feeding them with something that they can handle. Now, it's not entirely unheard of for there to be a bass guitar on this stage. It's not entirely, for there to be some kind of drums. I don't know that they have kick drums ever, but maybe. That would certainly be stretching this. This is a very live room. You see all this ceiling area up here. It's all hard surface, kind of reflective. It's a very live room. It actually has really nice intrinsic reverb. I did a gig here one time with Guggenheim Grotto, and during the sound check, before there was anybody in the room, they were like, wow, the reverb in here is great. And at the end of their show, they decided to do a song unplugged and walk out into the audience and, quote, take advantage of the natural reverb of the room, unquote. The problem is when the room's full of people like this, it doesn't have that reverb anymore. People are huge absorbers of sound. An empty room will sound different than a full room, and I'll talk a little bit more about that later. But by the time they went, as their show went on, I was adding reverb electronically. By the time they walked out here, it didn't have so much reverb. The other thing that was interesting about that show was they used a stomp box, which did need some bass. And actually, the Meandy has a kind of a bass guitar amplifier with like a crossover thing that we hooked up to get a little bit of thump. But generally, this is a great solution. These are really nice sounding speakers. It's a great solution. They're not super expensive. They're small and they work. But again, up high, acoustic music, live room. Now, this is an example. These are my ZX190s. You can see I have two here and two here. And these are the SB122 subs, two on each side of these as well. And this is in a high school gymnasium. This is the long wall of the gym. So I'm in the middle of the long wall. This ZX190 is pointed down towards this end of the gym. This is pointed a little bit turned out to cover across the gym in front of me, but also down a little bit. This one, again, is pointed out a little bit. This covers across the gym, and then this one covers down the gym. And then I've got the subs here. Now, the way this is set up, two SB122 subwoofers, and you can see here, so this is a 12-inch woofer. It's right under this grill right here. These are the vents that I talked about when you have a vented cabinet. So these are very, very efficient cabinets. These cabinets are not very big. They're like 35 pounds. I can pick one up in each hand and walk with them. They have molded in handles. Very easy to move. I just love these speakers because they will put out an incredible amount of bass. And the way that this is set up and the way that I did this, there's two of them on this side. These are 8 ohm speakers. When you hook them in parallel, you get 4 ohms. And this is hooked to one side of a Crown XTI 4000 amplifier. These two are in parallel, and they're hooked to the other side of the Crown XTI 4000 amplifier. What happens in that situation is that Crown amplifier will put out roughly 2,000 watts per channel. That's why it's called an XTI 4000, because it can put out 4,000 total watts. So you basically end up, the 2,000 watts are shared between these speakers on this side. So you get 1,000 watts in this speaker, 1,000 in this. 2,000 shared in this side, 1,000 in this, and 1,000 in this. On the top here, these speakers are not seeing anything above about 160 hertz because I've got an active crossover in this rack here. So there's an XTI 4000 amp in the bottom for the subwoofers. There's a crossover in here. And there's an XTI 2000 to feed these speakers. The XTI 2000 into, these are 8 ohm speakers. The two in parallel is 4 ohms. It'll put out about 800-ish watts. So these are each seeing about 400 watts. These are each seeing about 400 watts. With the bass taken out of them and playing music, they'll handle that. So I have a system here that in total is putting out almost 6,000 watts. This system, with this gym completely packed, this was like a freshman frolic dance or something like that, freshmen and sophomores. It was absolutely packed with high school kids, screaming, yelling, talking to each other above the music. Packed room. This system easily handled this. I was not driving it hard at any point during the night. Here's a third example. So this is something called the Lounge Stage at Falcon Ridge. Falcon Ridge Folk Festival is a folk festival held every summer, beginning of August. It used to be in New York on a farm. It is now done in Connecticut. Back when it was in New York, myself and some friends used to do a stage on Thursday night to open the festival. And this is in a tent. It's about 150 feet long and about 50 feet wide. And it's packed. There's 400, maybe even 500 people in this tent. And you can see up here on the stage, this is, primarily acoustic guitars and vocals. There is a upright bass right here, and there's actually a small drum set right here in this particular photo. But generally, it's acoustic guitar and singing. Sometimes there will be a bass player. Sometimes there'll be a small drum set. I'm doing this gig. These are, again, my equipment. These are SX300 speakers. So there's two here, two here. These are up on stands, so they're nice and high. You can see the people are sitting down. So this is nice and high, so it's projecting sort of over the crowd so it can get to the back of the room. These speakers have a 65 by 65 degree horn, so they're very directional. This one right here is kind of pointed at me. I'm mixing from back here. This one is turned in a little. This is turned in a little. This is turned out a little. So with these four speakers, I'm getting coverage of the entire room. It's reaching to the back. These two are in parallel. These two are in parallel. This is hooked to one channel of an XTI 2000. This is hooked to one channel of an XTI 2000. So again, about 400 watts into each of these speakers. These are very efficient speakers. I'm not turning, this system is coasting. And I've had a number of musicians who know sound sitting out in this audience saying it sounds really good. I've had several people who own recording studios tell me how good this sound is. These are spectacular speakers. And I have a little bit of EQ on them, not a lot. A little bit of equalization to smooth out a few things. Equalization is like salt. A little bit is great. If you're doing a lot of it, you probably need better speakers or something's wrong with the way your venue's set up. And a little more about the SX300. So I showed you that ideal curve before, and it was basically dead flat from 40 hertz, which is right here, out to 16 kilohertz, which would be out here. So here's the SX300. So if we go from 100 hertz here to 20,000 hertz here, you look at this, and if you've never seen these before, you're saying, well, that actually ripples all over the place. But actually, this is rippling within a few decibels, plus or minus a few decibels, 2-3 decibels. That's actually very flat for a PA speaker. And this is very good, very flat. Yes, at about 100 hertz, it starts falling off. By the time you get from 100 hertz, you're here. If you get down to around 60 hertz, 50 hertz down in here, it's about half as loud. So these are not going to make like a lot of 40 hertz bass. In that acoustic music situation where you have only small drum kits, you might have a bass player, but it's really not like dance music. You're not looking for pounding bass. It's not hard rock or rock and roll. These speakers are great. They do a great job. They sound really good. I've used 4 of these at a road race where there's like 1,600 people hanging out waiting for the race to start to broadcast sound out to them and play some background music and make announcements. And they work great. 1,600 people outdoors. 4 of these, they worked great. I've done high school graduations outdoors in a field behind a school, and you can hear the sound bouncing back. I'm behind an elementary school, and the high school is on the same campus, but it's like, I don't know, quarter mile away, half a mile away, and you can hear the sound bouncing back off of it. I mean, these things will throw sound a really long way. But be careful not to overdrive them in the bass frequencies. Now, the interesting thing is if you take these and you add the SB122 subwoofer, it basically takes this out to 40 hertz for you. So the combination of the two then gives you that complete range. And the next example I'm going to show you right here, this is Falcon Ridge now that it's in Connecticut. And this is their workshop stage. This building that it's in, it's a metal building. It's 60 feet wide and it's 200 feet long. Very, very live room. Concrete doesn't, concrete is actually reflects sound pretty well. And you've got this concrete floor with nothing on it. The roof is metal. That reflects it a lot. These joists here that hold the ceiling up, there's one of these about every 40 feet. And the front of them here bounces sound back. So there's a lot of sort of reflection. So the SX300s, again, here, 2 on each side, hooked to an XTI 2000. So there's 400 watts roughly in each one of these. They're very directional speakers. They're 65-degree horns. And so they're very good at beaming the sound down this room. And then on the floor here, you see the SB122s. Those fill in the bass down to 40 hertz. And in this case here, it's still, this is a folk festival. It's still acoustic music mostly. But at one point, we had 3 bass players on stage. At another point, we had 2 full drum kits and a percussionist on stage. Barely fit. This stage is 16 feet deep by 16 feet wide. Our plan is for next year to widen this out to 24 feet, to have more space. But these, sounded really good. I got a lot of compliments on the sound. Worked very, very well. And the fact that these are very directional was important in this building. I'd also point out here, you see these little rectangles here. These are monitor speakers, and they're on microphone stands. And we're going to talk about that some more in a few minutes. One of the things I think many sound people get wrong, and I think this is incredibly important, if this is the only thing you take away from this entire video series, when I get to a gig, the first thing I do every single time is I set up my speaker system and I start playing music and I make sure it sounds good and I dial in the speaker system. I have gone to so many concerts where you're sitting there before the concert and they're playing music through the speakers and it sounds like crap. And it's like, why don't you fix that? Because every decision you make mixing the rest of the night is going to be colored by that, and you can't fix it in the mix. You can compensate a little bit, but you're not going to fix it. You want to make sure that they sound good, that they're balanced correctly before you start. How do you decide if they're balanced right? Okay, well, if you have experience with this, if you know what good sounding speakers sound like, you can do it by ear. But if you don't have that experience, you're like, well, what the heck do I do? Well, you can play something called pink noise through the speakers. Pink noise is equal energy in every single octave. If you play pink noise through speakers and you look at it with an analyzer to look at the frequency response, it should be flat. All other things be equal. Now, I'm going to talk about in a minute, you don't actually want it flat. But if the speakers were perfect and you were in a room with no room reflections or anything like that, it would measure flat. You don't actually want that. I'm going to talk about that in the next couple of slides. But what you can do is you can go in and you can take these preferred listening curves that I'm going to show you, and you can just take your analyzer and you can look at it and go, okay, it doesn't look like that. And you can take an equalizer and you can adjust with the equalizer until you have the preferred listening curve. And you can do that. You don't really need any particular experience. And you say, well, how expensive are these analyzers? Well, when I started out in the 80s, they were thousands of dollars. But now it's an app for your iPhone. It's an app for your iPad. So the one I like, Studio 6 Digital, makes this audio tools. By the way, I'm not compensated by any of these companies, and nobody's ever given me anything for free. I bought all this stuff myself. So I have no reason to push on a particular brand or thing or anything like that. They make this audio tools. It's not that expensive, and there's all kinds of add-ons that you can put on it. It can do, you can have a sound level meter so that when you're doing a gig, you can make sure you're not playing too loud and putting people's ears at risk. You can, it has a third octave, analyzer that you can look at, or it has what's called a fast Fourier transform, which will give you every little frequency and peak and everything else. It has something called a spectrograph, which kind of goes across as you're playing, and depending on the frequencies, they're color coded, and so you can watch that and look for feedback. Tremendous tool to have. Highly recommend this. But if you're using it, you're going to want to adjust to the preferred listening curves. If you have good ears and you've trained them and you're comfortable dialing it in yourself, play some music through the system and adjust the equalizer until it sounds good. And you need some experience at that. You need to know sort of what frequencies will affect what things. We talked about that a little bit in the first part of this series. We've got a graph up on our website, the link below here, Scotten Jones /production. There's a chart on there that will help you with equalizing and things like that. couple of keys to this is, number one, make sure that the music you're listening to is well-recorded music. Because if you have a recording that has way too much highs in it, you're going to be turning down the highs on your speaker system, and then your speaker system is going to sound really dull. So you want to make sure it's well-recorded music. I'm going to talk about that in a minute. The other thing you can do is you can compare the live sound to headphones, and you can put the headphones on and off, but you need to make sure you have really good headphones if you do that. If it's not balanced right, if you have too much bass or you have too much treble or something like that, the first thing you want to do is try to fix it by moving the speakers around. There's a limit to how much you can do. Depending on the location, you might or might not be able to do much, but that's a good start. And then if you can't, then you're going to equalize it. And then the other thing is, keep in mind that if you get the speakers to sound good in an empty room, the balance will change when people come in. So you may have to make some adjustments on the fly. And it can change a lot or a little. Generally, it's not, it can change a lot. It really depends. The other thing is, when you're doing this, if you're listening to the music, it has to be at the same volume the performance is going to be. I was setting up for a gig one night. First thing I do, I get there, I set up my speakers, I've got music playing through them. And I've got a guy with me, and that was involved in booking the acts for the gigs, and he's kind of hanging out, and he's like, wow, this background music is kind of loud for background music. And I was like, it's not background music. I'm listening to the system. It has to be at the volume that the performance is going to be, because sometimes what will happen is you get up to a certain volume and something in the room will start vibrating at that particular frequency. So you have to be at the performance volume. Okay, so preferred listening curve. The speakers should not be set up to deliver flat frequency response to the listener. And you're like, well, wait a minute. We talked about speakers should be flat. You want them to be flat. The speakers, if you put them in what's called an echoic chamber, which is a room with no reflections, big, giant, very expensive test chamber, yeah, you want it to measure flat. But when you put that speaker in a room, what's going to happen is the basses are going to be accentuated, the high frequencies are going to be cut down a little bit, and that's what you're used to listening to. And here, for example, go to a concert hall, go hear a symphony orchestra. It's like this sort of ideal listening situation. You have these beautiful, incredible, instruments up on stage. We have these really, really good musicians. You're in a very well-designed concert hall. But what happens is you're hearing that orchestra at a distance. You are not up on the stage sticking your ear right next to a violin. You are not up on stage sticking your ear right next to a kettle drum, right? You're hearing it at a distance. And that concert hall and that distance is all interacting, and it's affecting what you hear. And these are a couple of curves that are put out. B&K is a big speaker manufacturer, European Broadcast Union. And then this is Sean Olive's curve, and he's one of those researchers that I talked about before. I actually prefer his curve. I like his curve right here, and I'll show you why. So here is measured frequency response in a bunch of concert halls. There's 3 different concert halls. There's a book called Halls for Music Performance that has dozens and dozens of measured rooms, although they don't really do the frequency response measurement on all of them, and some of them are very sort of broad. So I picked these 3 rooms because they were kind of representative and they had the data that I wanted. There is this big peak in this one room, which is, I don't know, something about how that room is designed, which is not really ideal. But if you look at this in general, it kind of slopes down. This dotted line is the Sean Olive curve. They all kind of do this same thing. There's a little bit of a curve to it here, but they all sort of drive down here. So this is what you're used to listening to. I had a big giant home stereo back in, I don't know, like the 80s. I had got an equalizer for it, and the first thing I did was play pink noise through it and set it to be flat. And it was awful. It was very, very bright sounding. And then I learned about the preferred listening curve, and I adjusted it to that, and I was like, oh, this is good. And this is sort of like how the whole music chain is set up, right? This is what we're used to. This is what you want. Okay, so I said you need to pick good music. So if you look at how a recording is done and how it's set up for, streaming or to go onto a CD, there's sort of three main steps, right? First, we record it, which is called tracking. Then it gets mixed. All the individual channels get balanced relative to each other. Effects are put on them, and they get mixed down to a stereo recording. And then it goes to mastering. And mastering is the final polish, little bit of equalization, little bit of reverb, maybe some compression. The guys that do that are some of the best ears in the world. These are people that really, really are incredibly well trained. And this guy, Bob Katz, he's like a top 10 in the world mastering engineer, maybe a top 5, one of the very best. And on his website, he has a list of CDs that are very well recorded and mastered. And so this is a list of 5 of them that I picked. You can go look at the list. There's a lot more on there. These are 5 of them that, I just picked out that I thought were ones that I would listen to. And, these are ones that you can use for tuning in your system. If you have a CD and the CD is really poorly mastered, it's really poorly mixed, and it has way too much high frequency on it, you're going to be turning down your equalizers and your system is going to sound very dull. If it's very boomy or it doesn't have enough bass, you're going to be misadjusting your bass. So you want to make sure that you have a really well recorded, good CD that you're using. Speaker setup. So the placement of speakers matters. Boundaries will increase low frequencies. A subwoofer on the floor will have more bass than if it's hung in the air. Put it near a wall. Put it near the floor and 2 walls in a corner. All these things will increase the bass. So to the extent that you can move your subwoofer around a little bit, this will help a little bit with the bass. You do need to make sure that your subwoofer and your main speakers are all equal distance from the audience. Otherwise, you'll have problems with the signal from the different speakers arriving at people's ears at different times. Surfaces can reflect or absorb mid and high frequencies, right? If the room has very live, hard walls, try to aim the speakers in a little bit so that they're not bouncing off the walls as much. Use your 65-degree horn speakers instead of your 90-degree horn speakers if you have them. Mirrors or glass surfaces can reflect high frequencies. I did a gig many years ago where the stage was facing across the room, and about 50 or 60 feet across the room was a gigantic mirror. And like all of the drum hits on the snare were bouncing back to the band, and they were going, 100, they were going 60 feet out to the mirror and 60 feet back. 120 feet's enough to put a pretty long delay in the sound. And it was like messing the band up big time. And so I tried to, reorient the speakers so they weren't aiming at the mirror as much. Limits to how much you can do. I had another gig where I got to this place and I set up, and it wasn't a very big room, and I had my SX 300s were going to be my main speakers for the night, and I was going to use my ZX 190s as monitors, or as part of my monitor system. And the sound was bouncing off the back wall, and it was awful. And I was like, well, I'll switch speakers, and I'll use the SX 300s for monitors because the stage actually had all kinds of heavy curtains all over the place. And so I aimed the ZX 190s, which are 90-degree horns, out at the room. They don't send sound as far, and it wasn't as much a problem. It sounded a lot better. And when people got in the room later, that helped as well. People are excellent absorbers. If you want to get sound to the back of the room, you got to sort of shoot the sound over them, and they will change the sound when they come in. So speaker height. So here's a situation where the speaker is sort of pointed right at the front row of people here. This person's getting blasted. They're absorbing some sound, so it's quieter here. And as you get farther and farther back in the room, and there'd be more than 3 people. But as you get farther and farther back in the room, it gets softer and softer and softer. And so it's too loud here, it's okay here, and it's too soft here. If you put the speaker up higher, it's actually not going to be as bad here for this person because they're at the edge of the speaker coverage now. And Back here, it's going to sort of be okay. You're going to get more sound back here. The other thing is a lot of times there'll be a ceiling like here, and it'll start hitting the ceiling and bouncing down to these people. So moving the speaker up and down can have a big impact on how far you're able to send the sound. So you need to think about these speakers. Now, the vertical coverage pattern of these speakers too is typically smaller than the horizontal. They're usually tighter. So, you just kind of think about it, look at it and say, where is the sound going to go? What's it going to hit? What's it going to bounce off of? You'll be shocked. I used to work this one room, a very large event room, and it had this big soffit down the middle of the room. Soffit, basically, it's a thing that sticks partway down. It's like a beam that's enclosed or something. It sticks partway down and over and back up on the other side. That would limit the sound to one side of the room versus the other side of the room to a really amazing degree. And so I would use my SX300s with the narrow tweeters, and I would shoot the sound under the soffit. So you kind of need to think about what's the angle of my speakers, where's the sound going to go, what's it going to cover. Delay speakers. So if you have a really long room, you're simply not going to get sound to the back of the room without it being too loud at the front of the room. Use directional speakers, put the speakers up high, but what you do is you can put delay speakers partway back down the room. Now, the reason you want to do this, the sound from the stage comes from the stage, it moves through the air at a certain speed. Sounds really fast, but it's actually not that fast in the sense that your ears are very sensitive to delays. And so if sound is coming from the stage, and now 75 feet back in the room, you have delay speakers and sound is coming out of those, the sound from the stage takes a certain amount of time to reach those speakers. The sound coming out of that speaker is coming out at the same time the sound is on the stage. You now have sound reaching the ears of the listener at two different times, and your brain and your ears will pick up on that immediately. So sound travels at 1.13 feet per millisecond. So for every 1.13 feet, you need to delay the sound by a millisecond. Or you need to delay the sound by 1.13 milliseconds for each foot traveled. So what does this all mean? This probably sounds confusing. So here's a diagram. Hopefully this will make it easy. So here's your main speakers. And each one of these arcs here is 25 feet. So 25 feet from the stage, the sound took 28.3 milliseconds to reach you. So from here to here, it took 28.3 milliseconds. From here to here, 56.2 milliseconds from the stage to here. And from here, it's 84.8 milliseconds. Here's your delay speakers. These are about 68 feet from the stage. So the sound to get to these delay speakers is 77 milliseconds. So if you were sitting right here and these weren't delayed, you would hear the sound immediately from the delay speaker, but 77 milliseconds delayed from the stage. 77 milliseconds is like, 0.8 hundredths of a second. You will hear that easily. I've taken a wireless microphone, and walked around in front of a stage 7,500 feet from the front of the stage. You say something into the microphone, like it's forever before you hear it. It's shocking how sensitive your ears are to this. So what you do is you delay the signal going to the delay speaker by 77 milliseconds. And now, like somebody sitting right here, they hear sound from the main stage about 85 milliseconds after it comes out the main speakers. The sound coming out of the delay speaker is delayed by 77 milliseconds. And then the other, 8 milliseconds gets made up for in the transit distance from here to here. And they hear it the same from both. And when you sit here and listen, you'll still think the sound's coming from the stage. Everything will be blended together. It will be good. Now, these are approximate distances and delays. The problem is that atmospheric conditions change the speed of sound. Not, grotesquely, but they change it. And so what you can do, use these as a guideline, and they make delay systems. They make delay systems for working with speakers. We'll talk about this kind of stuff in the fourth video when we talk about electronics. They make delay speakers. They make speaker management systems where you can dial in delays for each speaker. Sometimes you'll have mains that are at different places and you need to slightly delay them versus each other. Maybe you want to delay them to sort of match up to the instruments on the stage. All of that stuff, you can adjust all that in these speakers management systems. These are rough guidelines, but at the end of the day, you set this in there, put some music on, go stand out here and see if it sounds right. And if it doesn't, try adjusting the delay up and down until perceptually it seems like everything's coming from the stage. How much power do you need for your speakers? So speakers will have ratings. They'll have power handling ratings. Usually they'll have a continuous rating. They'll have a peak rating. Once in a while they have a music rating. Not that often. The continuous rating is a special signal. It doesn't change at all. It's driving the speaker continuously. And that will be the lowest rating. So say it's 300 watts. And this is from an actual speaker. It's rated for 300 watts continuous. It's rated for 1200 watts peak, which is for a very short period of time. Music is somewhere in the middle. So if it's 300 continuous and 1200 peak, probably can handle around 600 watts of music. Now, one of the interesting things is, if your amplifier is too big, as long as you don't, turn it up all the way and run it continuously at too high of a level, it's not going to hurt the speakers. If your amplifier is too small and you're overdriving it and it doesn't have like really good professional protection circuitry on it, it can go into a condition called clipping. And when that happens, basically all the energy goes into the high frequencies and it blows your tweeters out of your speakers. And so it's actually more dangerous to your speakers to have an amplifier that's too small than too big. Now, if you get a really good professional amp, like I use Crown professional amplifiers, they have protection circuits. They really don't let the amplifier clip. But it's very important. The other thing is speakers have an impedance rating, usually between 4 and 8 ohms. If you use them in parallel, 2 8 ohm speakers adds together to 4. So if you have 1 8 ohm, it's 8. If you have 2 in parallel, it's 4. Or if you have 1 4 ohm, it's 4. If you put 2 4 ohms in parallel, it's 2 ohms. By the way, your amplifier might not like 2 ohms, so you need to be careful. You need to look at the ratings on your amplifiers. But a lot of amplifiers, if they put out 200 watts at 8 ohms, will put out 400 watts at 4 ohms. My XTI 2000, I think it puts out 800 watts per channel into 4 ohms, and I think it puts out 400 watts per channel into 8 ohms. I think they're rated down to about 2 ohms, but one time at a gig I had 3 8 ohm speakers in parallel on each channel of an XTI, I think it was 1000 amplifier. So now you're talking 3 8 ohm speakers in parallel. That's, I don't know, it's like 2 or 3 ohms. The amplifier actually shut down at one point. So you want to be careful how many speakers you put in parallel and make sure that the amp can handle them. But it will drive up the power. And in the section on electronics, we'll talk about actually how to set up gain structure. And if you set up your gain structure correctly, you should never overdrive your speakers. Okay, so now we're going to switch gears. We've been talking about the main speakers for the audience so far. Now we're going to talk about monitor speakers, and these are what the performers use to hear. Now, for small to mid-sized venues, the bass from your subwoofers, if you have them, or the bass from your main speaker woofers, they actually wrap around the speakers, right? As I mentioned previously, the lower the frequency, the wider, the more it goes out. Bass goes everywhere. It's as you get to higher frequencies that it starts to come in and kind of beam out. And so you're going to get a fair amount of bass from the main speakers up onto the stage, probably. It depends on how loud you're playing them and where they are and everything else. But the monitors are going to mostly need to fill in the mids and the highs. So the monitors don't have to be gigantic speakers. You want them to be, aimed in such a way that the artist can easily hear what the monitors are putting out. You may have multiple different mixes. Like one artist might need to hear their own guitar and vocal more than anything else, but also wants a little bit of some other stuff. Another artist might want a different mix. So you might have multiple monitor mixes. So, you want the monitors to sort of be close to each artist, aimed at the artist so they can hear it. Ideally, the stage should be quiet. Ideally, everyone should be playing at, a reasonable level. The monitor should be set at a reasonable level. If you have an acoustic drum sit on the kit on the stage, it's going to have to be pretty loud because acoustic drums are loud, although the drummer can play louder or softer within reason. If you're in a small venue and there's a lot of stage volume, it's going to bleed out into the audience and it's going to make it hard for you to mix. So you want to keep the stage volume as quiet as you can, and it's better for the artists, it's better for their hearing. Monitors should be pointed away from microphones, and particularly the most sensitive pickup angle of a microphone. In the next video, we're going to talk about microphones extensively. Microphones have pickup patterns. Generally, like every microphone is most sensitive directly in front of it. They all are less sensitive as you go more and more to the side, but depending on what they are, some microphones are completely dead in the back. Some aren't. Some are completely dead off in various parts of the side. And we'll go through all that. We'll talk about where to put a monitor speaker depending on what kind of microphone you're using. In-ear monitors are great. You don't have to worry about in-ear monitors. Nobody else is going to hear what's coming out of them. They're not going to be picked up by the microphones because the big problem is that monitor speakers can cause the microphones to feed back. The problem with in-ear monitors is every person needs for sanitary reasons, every person needs their own earbuds. As a sound person who works, I do a lot of stages where there'll be 20 different acts in a few hours. I don't own in-ear monitors. I wouldn't work with it because I'd be constantly providing people with all different earbuds, and I use speakers for this. But if you're an artist, you could buy your own in-ear monitor system and bring it with you to gigs and ask them to use it. Point the monitors towards the artist's ears, right? The artist needs to hear. Floor wedges can work angled up. You can put them on a chair if you need to. The speakers that I've been talking about here, the ZX190s, the SX300s, you can use either one of those as monitors. They're actually angled on the sides specifically so you can do that. What I mostly use for monitors, I've had really good luck with, are small hotspot monitors. And basically, Galaxy Audio makes these speakers. They're 6.5-inch woofer and a 1.5-inch tweeter, not a 1.5-foot tweeter. That should be inch. They're very small, and you put them on mic stands. And so now they're up. They're at the artist's, above the artist's waist level, and they're sort of pointed right up at an angle at their ears. They don't need to be that loud. There's an insert on them that threads onto the mic stand and lets the artist hear very well. And I've had a lot of artists, at first they look at them, they're like, what the heck is this thing? But they usually like them. And here's some examples. So if you have a floor wedge, it's down here in the floor. Here's the coverage. The ZX190 on its side is a 50-degree angle. Person that's 5 feet tall, 5.5, 6 feet tall, they're at kind of the edge of the coverage of the wedge if they're close to it here. Now, if you're further back, then you're solidly in this pattern. But on a small stage, you're probably going to be pretty close. If they're having trouble hearing, you could put it on a chair. Now, if it's the front of the stage and they're the main act or something, this is not really all that aesthetic. So maybe you're not going to want to do this. But certainly, if I have somebody playing a guitar at the back of the stage or somebody playing drums at the back of the stage and they're having trouble hearing, or keyboards, absolutely put a monitor up on a chair. Another thing I don't directly address in this, but if somebody's playing a guitar amplifier or there's a bass amplifier or you have a keyboard amplifier, they make stands that tilt those, and that's a good idea too because it tilts it up towards the performer. The little hotspot monitors I was talking about, they're on a mic stand. They're very small, so they don't really block your view. I pointed them out on one of those other pictures before, and they're on a mic stand, so you can actually vary the height of them, although they won't get real low. I did have a situation last summer where people were sitting down to play, and this was a little too high. We actually moved them off the front of the stage and sat them on the ground in front of the stage. So that was a bit of a problem, but these work very, very well. I really, really like these. Feedback. This is the nightmare of every sound person, feedback. when sound comes out of a speaker, captured into a microphone, amplified, fed back out the speaker, where it's then captured again and amplified again, it goes in this loop, and it will run away, and it will just get louder and louder and louder. It's usually a very specific frequency, and it will just go totally out of control, and everybody in the place will be covering their ears. So what do you do about this? So a couple of things. First of all, feedback is typically a specific narrow frequency, and it's because you have a speaker that has a peak in its frequency response, or a microphone, or the venue has some weird resonance at a particular frequency. If you do a good job setting up your speakers and balancing your speakers, and so they have a nice flat frequency response, and they follow like this preferred listening curve, it's less likely to feedback. If you have good microphones that don't have massive peaks in them, they're less likely to feedback. If you have microphones that have tight pickup patterns, they're less likely to feedback. And we're going to talk about microphone pickup patterns in the next video. All those things will make your life easier. Point your monitors so they're not pointing into a spot where the microphone's going to pick up. That's going to make it less likely that you're going to have feedback. And we'll talk about that again in the next video when we talk about the microphone pickup patterns. If you get feedback, if it's a high frequency feedback, it's typically the monitors. The mains are pointed out to the audience. They're not pointed anywhere near the microphones. Typically, it's the monitors. If it's low frequency, it's typically wrap around from the mains. The first thing you do, you have feedback. You're like, oh my God. If you know what channel it is, and depending on what kind of board you have, you'll see that one channel, like everything will go red on it. Just turn the channel down a little bit to get rid of the feedback until you can figure out how to fix it. If you're not sure what channel it is, if it's low frequency, try turning down the overall volume on the mains a little bit. If it's the monitors, try turning down the monitors a little bit. Just to get it out of the way so it's not screaming in people's ears while you figure out what's going on. If you do a lot of live sound, when I was doing 125 gigs a year back in the day, if I had feedback, I immediately knew what frequency it was, and I could notch it out on an equalizer. You use an equalizer with a very narrow band, and you can notch it right out, and it goes away. I can't do that anymore. I have a reasonable idea what it is, but I don't have a super precise idea. I have my iPad sitting there running that Studio 6 digital sound tools, running what's called a fast Fourier transform the whole time that I'm doing a gig. And if there's feedback, you'll see the peak in the frequency curve, and you can then look and see what frequency it is, and you can then notch it out with an equalizer. The other thing that's good about running an analyzer like that while you're doing sound is if you look at it and it's like, wow, there's an awful lot of sound around a certain frequency, and you're sitting there and you're going, why does this sound too full, or why does this sound dull? Or you can kind of look at that curve and get an idea of what's going on as well. So your ears are the ultimate decider, but you can use technology to augment your hearing to help you figure this stuff out. So notch the feedback frequency out with a narrowband equalizer. The other thing you can do, and the other thing is when you set your monitors up before the gig starts, set them up, turn them up, go up in the stage, kind of cup your hand around the microphones and make sure you don't get feedback. And if you do, figure out what the frequency is and notch that out in the monitors. The other thing you can do is a lot of mix boards have parametric equalizers. And what a parametric equalizer is it'll say, oh, this is the mid-band equalizer. And you'll be able to set the frequency, how wide the band is, and how much cut or boost there is. So if you think you have feedback somewhere between 500 and 1,000 hertz, say, take that parametric equalizer, turn it up a little bit, set it to 500 hertz, set it to a fairly narrow band, and then start turning the knob from 500 to 600 to 700 to 800 to 900 to 1,000 and see in there where it starts feeding back. And once you do, it's like, oh, that's the frequency, and then you turn it down instead of up, and it goes away. I've seen people, inexperienced sound people, or people who haven't done it in a while, and they're having feedback, and they're in a panic, and they don't know what to do, and it's feeding back and feeding back and feeding back. Just turn the volume down. I mean, yeah, it'll be a little softer than you want. It's not ideal, but just turn it down a little bit till you figure it out. So, conclusion. Selecting good speakers is essential for good sound. Combination of specifications and listening should be used for speaker selection. Always, always, always set up and tune your speakers at the beginning of each gig before you start mixing. God, how many times I've gone to a gig and it's like, yeah, this is going to be awful because the speakers sound terrible before the gig's even started, the music they're playing through it. Every decision you make mixing is going to be made through those speakers. And yeah, if the speakers are boomy and you have good hearing, you're like, oh, well, I turned down the bass guitar, and yeah, that'll help, but fix them first. You can do it with pink noise if you can't do it by ear, or you can do it by ear. Monitor speakers are essential for the artist to hear. They primarily need to provide the mid and high frequencies because the lows wrap around from the main. And like I said, I've had really good luck with hotspot monitors. And there are resources on our production page here. This presentation will be up there. You can download it. There are some other reference materials. There is the presentation for the other videos in this series will also be up there as they're released. And it's free. It's free. I'm not doing any of this for money. So thank you for your attention. I hope you found this useful. And again, there'll be another video coming, not too distant future, covering capture, which is microphones and direct boxes. And finally, there'll be one on electronics after that.